Let's do it. All right, so in exercises 1 through 4, find the value of each variable in the parallelogram. What's one equation, peeps? Nico, give me one.
It's going to be x plus 3 equals 17.
Why?
Because since those two sides are going to be equal to each other.
Why are they equal?
Is it parallel?
Uh-huh. Why else? Who knows why those two have to be equal? They're congruent. It's a parallelogram. Opposite sides of a parallelogram have to be equal. If it didn't say that these were parallelograms, those would not necessarily have to be equal. Do we understand that? Okay. All right, so x plus 3 equals 17. So what is x, Samantha? 14. Okay. What about y? Y minus 2 must equal? 38. So y is 40. Pretty easy. What about number 2? Give me the equation for A. Someone. Good. A plus 5 equals 15. So what's A? 10. Awesome. Good. What else? How do we solve for B?
111 equals 3b.
Good. 111 equals 3b. Why? It's a parallelogram. And what's true about parallelograms?
The ones that are across from each other are congruent.
Good. The angles that are opposite each other. See how these two angles are opposite each other? They must be congruent. Those two have to be the same. What's true about angles that are next to each other in parallelograms? They equal 180 when you add them together. What's another word for that, guys? Starts with an S.
Complementary.
Not complementary. Supplementary. Okay, they are supplementary. Okay, so 3b equals 111. B equals 37. I think. Yes, 37. Are we all good on the warm-up? Okay. Lesson 7.3, guys, is all about proving that a quadrilateral is a parallelogram. So you remember all that stuff that we learned about parallelograms, how opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other. We're using all those theorems, but in reverse. So if we have a quadrilateral where two opposite sides are the same, then it's a parallelogram, okay? We're proving that figures are now parallelograms. Not saying, okay, this is a parallelogram, what do we know from there? It's doing the opposite. So it's a bunch of converse theorems, okay? The first one that we're gonna talk about is the parallelogram opposite sides converse. If both opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram, okay? So if BC is congruent to AD, and CD is congruent to AB, then we have a parallelogram. So let's go ahead and write the if-then statement. So if AB is congruent to CD and BC is congruent to AD, then ABCD is a parallelogram. This is the converse, right? The converse says if we have two opposite sides that are congruent, then we know it's a parallelogram. The regular theorem says if it's a parallelogram, then opposite sides are congruent. They're different. One if is if it's a parallelogram, and the other if is the two sets of congruent sides. The if and the then change. That's why it's the converse. Okay, moving on.
Thanks.
You guys got 30 seconds, or else you'll have to watch my video and listen to my annoying voice twice. Gosh, that's torture. So copy fast, people. Ten seconds. Okay.
Wait.
Whoa. Theorem 7.8. Opposite angles converse. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Same thing here, guys, okay? So if we can prove that both pairs of opposite angles are congruent, we've got a parallelogram. But the if and the then are flipped. That's why it's called the converse. So if angle A is congruent to angle C and angle B is congruent to angle D, then ABCD is a parallelogram. Remember that slanted box is the just symbol for parallelogram. If you forgot it, just write it down again, parallelogram. Because we'll be using that to abbreviate a lot in these lessons to come. If you want to highlight these bad boys in one color, so like B and D in blue, and A and C in another color, just to have it really pop out, stand out for you, be my guest. So again, guys, I'm going to say this one more time. Before, our if was if it's a parallelogram, then we know all this information. We're doing the opposite now, okay? So if we have two pairs of opposite angles, then we can conclude it's a parallelogram, okay? If we have two pairs of congruent sides that are opposite each other, then we have a parallelogram. The then is now that it's a parallelogram. So we're doing the opposite. That's why it's called the converse. Okie doke. Theorem 7.9. Opposite sides parallel and congruent theorem. If one pair of opposite sides is a quadrilateral, are congruent and parallel, then the quadrilateral is a parallelogram. So if BC and AD are parallel and also congruent, we've got a parallelogram. So if BC is parallel to AD and BC is the same length as AD, or it's congruent to AD, then AB CD is a parallelogram. Peeps, please notice the difference here. Do you see the difference between the top figure and the bottom one? See how those congruent symbols are on the other sides? This is not enough information to determine that it's a parallelogram. Okay? It's not the same, right? Not enough info. Okay, the pair of congruent, the parallel sides need to be congruent, not the other sides, okay? If it shows that two of the sides are congruent, they need to be the two sides that are parallel. Does anyone not see the difference between the top figure and the bottom one? Speak up now. Okay, and the last theorem for this lesson. Parallelogram diagonals converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. That means if each of the diagonals cuts each other in half, do you see how it cuts each other in half? Then we have a parallelogram, okay? We're gonna label this point in the middle, point E. And we're gonna write if BD bisects AC, and AC bisects BD, then ABCD is a parallelogram. Okay, moving on. All right, guys, this is a nice little summary slide. If you want to write at the top of this slide, it's a summary. That's a good idea. Summary. Okay, there's 5 ways to prove a quadrilateral is a parallelogram. You can show both pairs of opposite sides are parallel. That's just the definition of a parallelogram. The second way is to show both pairs of opposite sides are congruent, show one pair of sides are congruent and parallel, and show both pairs of opposite angles are congruent, or show that the diagonals bisect each other. 5 different ways. On the next slide, it is also the same 5 ways, but they've got pictures, okay? This is also a summary page with pictures. Go ahead and put summary, but with pictures. Or with pics, okay? Nice little diagrams for you. Remember, if both pairs of opposite sides are parallel, that's just the definition. And then we've got 4 theorems after that, okay? Now, when you guys are doing your homework, please do not put the theorems, like 7.7, 7.8, 7.9, 7.10. I want the actual name of the theorem, okay? So opposite angles converse, opposite sides converse. Okay, peeps. Example 1. State the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. Again, my apologies, when it was printing, it didn't print very well. This should be a slanted parallelogram, so go ahead and draw a line from B to A and from C to to D. Should look more like that. And not with this extra part. My bad. If you can write over it in white to take it out, that would be good, but it should look like that. It should look like a parallelogram. Actually, let's just draw it again. And this almost looks worse. E, B, C, D, and A. Okay. So in number 1, it says BE is equal to ED. CE is equal to EA. What theorem could we use to prove that the parallelogram, or that this quadrilateral is a parallelogram, based on the given information in number 1?
The diagonals, converse diagonals.
Good. Converse diagonals, or parallelogram. It's actually the diagonals converse. But awesome. Why, Teresa?
Because it says that BE equals ED and CE equals EA, and those are the diagonals.
Good.
So,
This is congruent to this, and this is congruent to this. That's absolutely the right way to word it, okay? If your diagonals bisect each other, that is a parallelogram. Beautiful. Okay, angle BAD equals angle DCB. And angle ADC equals angle CBA. What theorem?
is it the parallelogram opposite angles converse?
Good. Parallelogram, opposite, angles, converse. A lot of abbreviations here, okay? So I abbreviated the parallelogram by just drawing that symbol, and I abbreviated the
can't see your
angle.
screen. It says like air server.
Ugh, what just happened? Why did that happen to me? Hold on, hold on. Are we back? How about now?
Yes.
Yeah, there we go. So parallelogram, opposite angle, converse. Who can tell me why it's the converse? Please, 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 someone tell me why it's the converse.
Because both pairs of the opposite angles are like congruent.
Uh-huh. But why isn't the converse not the regular parallelogram theorem? It's the converse, guys, because we're proving that it's a parallelogram. If we know it's a parallelogram, we use the regular opposite angles theorem to say that both the angles are congruent. But when we're saying that it's a parallelogram, that is the converse, okay? All right, BC is parallel to AD. AB is parallel to DC. This one is just an example of the definition of a parallelogram, okay? This is definition of parallelogram. Okay, for number 4, we're missing some symbols. Go ahead and put a line above each of the double letters and a congruent symbol. If BC is congruent to AD and AB is congruent to DC, what theorem are we using there to say that it's a parallelogram?
Parallelogram opposite sides converse.
Good, Teresa. Parallelogram, opposite sides, congruence theorem. Or I'm sorry, converse. Converse theorem. And my last one, BC is parallel to AD, and BC is also congruent to AD. This one is not a converse, guys. It's just opposite sides, congruent, and parallel theorem. Okay? If you can prove that two of the sides are parallel and congruent, they have to be the same two sides, then you have a parallelogram. All right, 3 examples total. So we got 2 more. Example 2. For what values of x and y is quadrilateral PQRS a parallelogram? What do you think we do?
X plus 9 equals 2x minus 1.
Good. Because opposite sides have to be congruent, okay? So let's write that theorem. We're going to use the parallelogram, opposite sides converse. And yes, I would expect you to write the theorem for these types of problems. So on your homework, it's not enough to just write x plus 9 equals 2x minus 1. Write down the theorem that you use to assume that, okay? A lot of you are seeing explain in your homework and you're not actually explaining. That's probably why you got an 80 on your homework. If you're one of those 80 people, double check that you're actually explaining when it says explain. If you got 100, I appreciate all that you do. If you are not getting 100 on your homework, it's because you're probably forgetting to explain stuff. Okay, so parallelogram, opposite sides, converse. So this is x plus 9 equals 2x minus 1. How do we solve this? Samantha, give it to me.
100 minus x minus x.
Mm-hmm.
And then x minus 1 equals 9.
Mm-hmm.
And then plus 1 plus 1, and I got x.
Good. 10 equals x. How do we find y, peeps? Noah?
Look at what you got from x, where it says x plus 7.
Mm-hmm.
Is y 17 because x is 10, so 10 plus 7 is 17. And then both sides are congruent.
Yep. Noah, how'd you get it?
Well,
So you plugged in 10 for x.
looking 10 for x, which is 317.
Good. QR and PS must be congruent. Why? But what's so special about this figure? Very good. We're trying to prove that it's a parallelogram. In order for it to be a parallelogram, opposite sides need to be congruent. So now we've got y equals x plus 7, which is just y equals 10 plus 7, which is y equals 17. If it was asking us for the length of SR, what would we have to do?
Plug in 10 for x.
Good. We plug in 10 for x for SR, and we would get 19, okay? Make sure you are reading the questions carefully. It starts with your homework, guys. If we're not reading the questions carefully on the homework, we're definitely not going to be reading the questions carefully on the test. So make sure you're reading your questions carefully. Okay, Last example. For what values of x and y is quadrilateral ABCD a parallelogram? How are we going to set this one up? What theorem should we use?
The parallelogram opposite angles converse.
Good. Parallelogram opposite angles converse. And we're going to get two sets of equations. What's one of them?
4y equals y plus 87.
4y equals y plus 87. What's another one?
3x minus 32 equals 2x.
Good. 3x minus 32 equals 2x. Let's solve the red ones first, the ones with y. We're just going to subtract y from both sides. We get 3y equals 87. We divide by 3, divide by 3. And we should get like 19. Y equals 19. Did anyone else get that?
I got 29.
It should be 29, you're right. Thank you. 29. That's a 29, guys. Sorry. And then the blue one. What'd you guys do?
Minus 3x.
What'd you get?
Negative 32 equals negative x.
Mm-hmm.
Divide negative x by negative 32 and get positive 3.
Okay. X equals positive 32. If it asks us for angle B, what would we do?
Plug in 29, so 29 times 4.
Good. We would plug in 29, so it would be 29 times 4. If it asks us for angle C, what would we do?
Plug in 32.
Yep, plug in 32, so you'd get 64. Okay, awesome, guys. Go ahead and submit these.